All right, up to this point, we talked about the heart as the pump, which pumps blood into the lungs, through the pulmonary arteries, as they branch off into smaller vessels until they become the capillaries surrounding the alveoli. At the respiratory exchange membrane, they're going to pick up oxygen and then travel back to increasingly larger vessels, which are going to become the pulmonary veins, dumping blood into the left atrium. And that oxygenated blood is then pumped out, destined for all the systemic circuit for gas exchange in all body tissues. But the first stop really in that systemic circuit is to supply the heart itself with fresh blood. So when we're talking about this coronary circulation, it's going to be about blood flow through the cardiac tissue as like any organ rather than blood flow through the pump. So as blood is being forcefully ejected from the left ventricle through the aortic valve, it is immediately channeled into arteries branching off to the left and right to supply the heart with oxygenated blood. These are the right and left coronary arteries, which soon are going to branch off in different directions and take on different names as they do so. As this is the beginning of the coronary circulation, feeding oxygen and nutrients to the muscle tissue of that hard-working heart and draining that tissue of oxygen-depleted blood right back into its right atrium. All right, so the left coronary artery branches right away here. One branch, the circumflex branch, is going to wrap around the AV border to the left, and then the other, the anterior intraventricular branch, toward the apex within the intraventricular sulcus. So these branches are going to diverge into smaller vessels, then into capillaries, which will supply this cardiac tissue with oxygenated blood, and those capillaries will pick up carbon dioxide and other waste and converge onto larger veins, such as the great cardiac vein, draining the heart on the anterior side. So this anterior interventricular branch of the left coronary artery is commonly known as the LAD, left anterior descending artery, and also has the nickname the Widowmaker. The arteries, unlike the veins, are under tremendous pressure. And the closer the arteries are to the heart, the more pressure they're facing. So all these coronary arteries are under much more extreme conditions than the more distal arteries. Small damage to the vessel wall here that may be tolerated elsewhere are going to accelerate into major problems. The left anterior descending supplies a large portion of the left ventricle with fresh blood, and blockage of that supply is going to result in near immediate death of the cardiac tissue and stoppage of the heart. Even partial blockage is going to decrease flow to the intraventricular sulcus area, which will also kill off cells of the AV bundle branches and the conductance system. And so the result is a block of the impulse conduction between the atria and the ventricles. So when this narrowing or blockage is severe enough, a coronary artery bypass graft can be used to provide blood flow around the block area. This involves using an artery or vein and stitching from the aorta to below that blocked area to bypass it and restore blood flow to the area beyond it. So that's the LAD running down the anterior intraventricular sulcus, and on the posterior side of the heart, you're going to find the posterior interventricular branch of the RCA, the right coronary artery, otherwise known as the PDA, the posterior descending artery. And running alongside it is that middle cardiac vein, and all the veins of the heart are going to ultimately converge and drain into the coronary sinus. The coronary sinus is a collecting vein that drains directly into the right atrium. So the heart veins have their own private entrance to the atrium, whereas blood from everywhere else in the body enters the right atrium through the superior or inferior vena cava. So these are the major blood vessels of the heart you're going to want to be able to identify. But also it's useful to keep in mind a specific organ like this when you're talking about systemic circulation, which will be our next topic. So there we're going to cover circulation patterns in general throughout the body, how the big arteries branch off into smaller arteries, branching out into the capillary networks within the body tissues, and how the capillaries drain into venules and converge into larger veins, bringing blood back toward the heart. The big arteries leaving the heart will have different functions from the arteries that branch off of it, and these are going to be reflected in the makeup of the vessel walls. So in general, we're going to want to look at the big patterns of blood flow out of the aorta, those first major branches off the aortic arch, and the general patterns of distribution toward the head, upper limb, abdominal region, and down toward the lower limbs. First, get the names of the large so-called conducting arteries, mostly those off the aortic regions and their first large branches, and then work your way into the distribution arteries, which are most of the named arteries that you're going to have to know. All right, more on that next time. I'll see you later.